And we're back. Hi, Verge.
Hi, Mark. Welcome to our next session of AB Live.
That's what this is.
Uh-huh.
I am Mark Corrali from Ryan High School in Denton, Texas.
Verge Cornelius, Lafayette High School, Oxford, Mississippi.
And you should be here for AP Calculus AB. We are wrapping up Unit 8 today, and that's exactly what the title is going to be, is Unit 8 wrap up. And then we're going to start the sprinting marathon of review next week, for the next 3 weeks.
Mm-hmm.
And that sprint leads up to that May 12th exam at 2 p.m. Eastern, 45-ish minutes. And this slide is repeated at the end. And that address at the top, apcoronavirusupdates.collegeboard.org, has even more details for you.
So this is our slide that we've had for quite a while now, and we've been updating it by how many days we've gone without any sort of a correction needed or oversight. And so far, we're back down in the lower numbers. We're at 1. But this is a new picture of us that we just got yesterday. Mark, want to talk a little bit about it?
Yeah, we got a email from 2 students, actually, the artist and her friend. And it's actually a 2-frame cartoon, but this was the first frame. And since we put a picture of ourselves up, and each time we've started a new run of error-free, we've put a new picture up, and we'd actually picked a picture out for today, and then I got this email, and I'm like, I immediately emailed her back and said, can we use it? This is great. And I was impressed. As little as we are up there, got the details on the shirt, and it's very cool.
My neck is so thin.
Yes, yes, very flattering. And then later in the day, we got another one because Verge had kind of put out there about the 11 joke, if we could have some cartoons. So here's we did get permission from both students, but thank you. And thanks to everyone else. We do get notes that say, you've enjoyed watching us or whatever. And we appreciate it. We really do. Even if it's one I get late at night, I forget to respond or something, trust us, we do read them and we do appreciate it.
And this reminded me that I had gotten sent some art early on, maybe the first or second lesson. An art student in Florida had sent me some art that he had done based on the notes. And I'm going to have to dig that up in my email and see if we can't get permission to share that at some point.
So there's your introductions and banter for April 10th. We're about to do our warm-up. Our Unit 8 conclusion is going to be mostly free response practice. And then we'll wrap up and let you know what's in the Dropbox. So here's your warm-up for today. This is a new problem. It is based on what we did yesterday, but it is a new problem. It says let f of x equal x cubed plus 2 and g of x equal x plus 9. Find the area of region R bounded by f of x, g of x, and the vertical lines x equals -2 and x equals 2. And we even provided a nice little graph over there to the right for you. And so you can pause us and work this problem, or you can work it while we talk. And Verge.
Yeah? You want me to tell a joke or something?
You could.
Okay, so somebody sent me this joke. And I'll talk about the Mobius strip later when I'm on my overhead.
Okay.
I'm not going to switch to it now because Mark's going to switch to his overhead.
That's right.
But here's the joke. Somebody sent it to me. What's a math teacher's favorite tool?
What is a math teacher's favorite tool, Verge?
Multipliers.
I kind of like that one. That is not horrible.
Yeah, but everything's relative, right?
Yes, exactly. Yes. I may not be the best judge of that, but in my opinion, yes. All right. So can you see my cam, Verge?
It looks amazing.
Hey,
yes.
Okay. So hopefully you can't see the cam, right? That'd be weird.
That's true.
So again, we're doing an area between 2 curves. And my bounds are pretty obvious from this. I think it's -2 to 2. If I pull my cursor over here, which function's on top? Well, this one has this little 2-turn S curve, and that one has no turn. So I'm looking at g of x is on top and f of x is on bottom. That's kind of important because what is our formula that we started with, right? Our general form was a to b f minus g, but in that drawing f was on top. So we want to make sure we look at that, or wrap it in absolute values if you want to be extra safe. So g of x is x plus 9. And then this is what I was talking about at the end of the video yesterday, that you want to be very cautious that you're subtracting all of f of x. And I'm going to just gather things. I've got a negative x cubed and x, and 9 minus 2, I think will be 7 today. And because this is the warm-up, I'm going to go a little quicker, but we're going to add 1 to the exponents and divide using power rules. So negative 1/4 x to the 4th plus a half x squared plus a 7x. Evaluating that from negative 2 to 2. And again, I'm going to do some things a little quicker. 2 to the 4th is 16. 2 squared is 4. And 7 times 2 is 14. That's silly to write that one out.
Oh, you just want to use that erasable pen.
Yes.
We love our erasable pen.
All right. And then we're going to plug negative 2 in. Well, negative 2 to the 4th is still a positive, but we have that negative out front. Likewise on the square. So we've got 4 over 2 again. And minus 14 on the end here. And if I look at my signs, I've got a 4/2 minus a 4/2. A negative 16/4 minus a negative 16/4. So I think those all cancel.
That's, yeah, very nice.
And so 14 minus negative 14, 28. And I'll be honest, I haven't done it. So I'm going to really quick check that, but I will check it and get back to you. So.
Actually, I did it this morning and it's correct.
Oh, well, excellent.
Let me put it this way.
We agree.
I also got 28. Yeah. So chances that it's correct are pretty high.
All right. Thank you.
Yeah. All right. So great. And I'm glad we got a chance to see that minus something other than a single term there, where you have to be cognizant of distributing the negative.
We have a third source now. So.
Okay, good. And you typed it in properly, so that's good.
Or I repeated whatever mistake I did in pen, yes.
Okay, so we're going to go ahead and do our wrap-up lesson today, and we have selected several previous free response questions. They were like old friends to me when I went ahead and, you want me to grab the screen, Mark?
Sure.
Okay, when I went ahead and
oh yeah, you got the gray box up there. Probably did. I did it.
No, it's good. When I went ahead and started working on these this morning, I had done them all already in the past, but in any case, I hadn't done them in a while, so that was kind of fun. They were like old friends. So today is Friday. Some of you might be joining us on Monday. Several districts and schools might have today off for holidays and things like that. But in any case, it's our 13th AP Live.
So it's kind of Friday the 13th in a sense.
That's what I was thinking. That you picked up on that, Mark. Okay, good. Before we go into those, before we go into those free response questions, I do want to wrap up Mobius Strip information. Remember, this is just a little loop, and if you cut it in half, you get 2 loops. So just a little loop. If you cut it in half, you get 2 loops. When you cut the Mobius strip down the center all the way around. Did anyone out there do it? I bet several of you did, because you've sent me great pictures of the Mobius strips you've made yourself. Mark, what do you think is going to happen?
I'm sorry. My daughter's trying to get to her hot chocolate that's across the room, so I had myself muted. I think since you're cutting that one side in half, you're still going to have one side.
Yeah, still one side. And what's interesting, first of all, that's kind of a shocker to some folks, but also now there's 2 loops. And I'm not going to spend any more time on this, since we're doing calculus, not topology, but I would encourage you who've already cut it once, if you haven't cut it twice, I would encourage you to do it again sometime this weekend and see what happens. I love it when people are curious about stuff. All right, so we're going to do for sure 2 free response questions. This is from the 2016 practice exam. And Mark is so clever the way he puts these little 8s all the way across, just like the AP booklet in which you would write your answers on any other year. In any case, I'm going to go ahead and read this stem here, this given information, and then we'll work on parts A, B, and C. So in this problem here, it says a hive contains 3,500 bees at time t equals 0. During the time interval from 0 to 4 hours, bees enter the hive at a rate modeled by E of t equals 16t minus 3t squared, where E of t is measured in hundreds of bees per hour. During the same time interval, bees leave the hive at a rate modeled by L of t equals negative 2t plus 15, where L of t is measured in hundreds of bees per hour. And then in part A, it says how many bees leave the hive during the time interval 0 to 2. So I'm going to go ahead and make some more Mobius strips here, just so that we can focus only on part A. Put that to the side and I can write. So in part A, again, it says how many bees leave the hive during that time interval from 0 to 2. So I'm looking for hundreds of bees that are going to leave the hive.
That's a perfectly reasonable unit, by the way.
The
hundreds of bees, right? HOB is perfectly legit.
Reminds you of the hundreds of elephants or something like that, or hundreds of entries on the elephant. Yeah. Okay. All right. So how many bees leave the hive during that time interval? I'm going to need to use this function here. And I'm going to go ahead and integrate from 0 to 2. Ooh, that looks like a 6, but it's supposed to be a 0 of L of t dt. So that means I'm going to say the integral from 0 to 2 of this linear function, negative 2t plus 15 dt. This was a no calculator question. Of course, on this year's exam, calculator is going to be able to be used on everything. So you could go to your calculator and evaluate that. But in any case, in real life, not in 2020, in real life, we all need to know how to anti-differentiate here. So negative 2t squared, or sorry, negative 2t, the antiderivative is negative t squared, and then plus antiderivative of 15 would be 15t.
Yep.
I would have to evaluate that from t equals 0 to t equals 2. So I would have negative 2 squared and then plus 15 times 2, and then minus, these are both going to be 0 when I'm substituting into the polynomial. Unlike what Mark did in the warm-up, where we had a lower bound that was, like negative 2 in the warm-up, we really had to be careful about substituting in there. But this all goes to 0. So negative 2 squared is negative 2 times 2, which is negative 4, and then plus 30. So getting 26. And then this is, what are my units? Hundreds of bees. I guess you could go ahead and write this as well. Would that be good, Mark?
Is that 2600s or 26,000?
That would not be good.
I was about to suggest 2600, but
yeah. So that would be better, right?
Yeah,
2600 bees.
Either
okay,
one
good.
would be. But also notice that Verge didn't put an equal sign there.
Mm-hmm.
Although I guess that would technically be correct with the units.
Mm-hmm.
But what you don't want to do is have that original integral equal to 2600.
Mm-hmm. And I think really I'm playing with fire here, because if I'm looking, if I'm thinking back to what I did earlier today, I never did this.
Yeah, it's a dangerous game, and this is important for those of you that are taking the exam, because if you write the integral equals 2600 and you don't say of bees, you're in a fuzzy land, because that function equals that expression, that integral of that integrand equals 26. And if you start saying it equals something it doesn't, you are playing with fire, as Verge said. So.
Well, and I think too, because we've gotten some comments about units and things like that. Here, I was never explicitly asked for the units. you
True.
know? So actually I can just leave my answer as
Well, no, you are.
26.
Well, let's see. How many bees leave the hive during the interval? 26. I
Oh,
don't agree with that.
okay. Then I'm with you.
Yeah. I think we go back to the question and make sure we answer the question, but also make sure we don't have any false equivalencies. Right?
I might not have much eraser left after this.
You never use the pink one. Just go grab the pink one and use its eraser.
Yeah. Okay, that's my answer to A, 2,600 bees. All right. So in part B, and we haven't read part B yet, I'm going to go ahead and cut it.
It's not that you're cutting it; it's the fact that I can hear it. It's just
You
like,
can hear the scissors.
Yes.
Zoop, zoop, zoop. I'm going to go ahead and cut
Snip,
this
snip,
part
snip.
off too. These are, in a
Yeah, the
house when
confetti.
you have kids, like this is the best I can do on scissors. The Hello Kitty scissors from I don't know when. Okay.
Hold on. Sorry, unplanned steal. Because I just reached 2 feet behind me. That's. I have a 12-year-old, and
Yeah,
these are on the shelf behind me because of the 4-year-old, right?
Yeah, that's the best that you can do on your scissors.
All right, go ahead and grab that back.
Okay.
Oh, we stopped share completely.
All right, back to me. Okay, so here's my B. It says write an expression involving one or more integrals for the total number of bees in hundreds in the hive at time t, for t is in between 0 and 4. Find the total number of bees in the hive at t equals 4. So again, write an expression involving one or more integrals for the total number of bees. This kind of reminds me of what we were doing yesterday, where we've got this initial amount. So it starts with 35 plus bees are entering, and they're entering at this rate E of t right here. So the integral from 0 to 4 of, you can write E of t dt, or you can write that binomial right there would be fine. And then they are leaving at this rate right here. So leaving indicates that you would subtract the integral from 0 to 4 of the leaving bees, the bees that where the rate is going out. Okay.
Yeah, it's the pipe. It's the water tank, right? The pump
Yeah.
in, pump out. Yeah.
I was trying to remember what the actual problem was, but that was what we did on the warm up, wasn't it?
Yeah, it was the 30-gallon water tank.
It's exactly the same. That's right. Okay, so so here I want to go ahead and then figure out each of these. I feel like, did I already figure out no, I went 0 to 2 on the other one. So dang, I have to do that all. But anyway, 35 and then plus, I'm going to go ahead and figure this part out. So 0 to 4 of 16t minus 3t squared dt. I'm just going to only work on this part right now, if you don't mind. So antiderivative here is going to be 8t squared and then minus t cubed from t equals 0 to t equals 4. So substituting in the 4, 8 times 4 squared, and then minus 4 cubed, and then minus, again, substituting in 0, 0 minus 0. So 8 times 16, and then minus, what, Mark? Am I messing up?
No, it's just a big number.
Okay, I'm just going to leave it like that then. We're just going to leave big numbers laying where they are. No, we're
it's
not going to poke
It's
it.
128. We know it's not that big, but
okay,
it's still just.
Maybe it'll cancel out with something else. I'm optimistic. All right. On this one, the L of t, that would be the integral from 0 to 4 of negative 2t plus 15 dt. And we already figured out that was negative t squared plus 15t. Evaluating that from 0 to 4, I get negative 4 squared and then plus 15 times 4, and then minus that part's going to 0 again. So negative 16 plus 60. So I've got 35 plus, you said 128, and then minus 64, and then minus 16, and then plus 60. And that would be the total number of bees. And I did this earlier today and came up with 5,500 bees. How does that look, Mark?
Are you subtracting out that entire integral on the right, or did you add it in?
Dang it. Okay, this one right here. Is that what you're talking about?
Yeah, that makes it a lot
Much
closer
better.
to 55.
Oh, it is so Friday, isn't it? Oh my gosh, my head is in a fog. Is that better now?
That looks much more like 39 plus 16 to me. Okay, good. All right.
Okay, because that's 44 there. Okay.
Yeah.
Okay, good.
Yeah, now you're good.
And yeah, now I'm good, but now I have to do the hardest part.
Good to have two sets of eyes. That's
totally. I'm excited to watch you do the rocket problem.
Me too.
All right. So here's part C. And I'm going to go ahead and make sure the stem is showing. In part C, it says find the minimum number of bees in the hive on that interval from 0 to 4. Justify your answer. Okay. So the minimum number of bees is going to occur. I'm going to move this little thing on my screen. The minimum number of bees, this to me sounds a little bit like extreme value theorem or something like that, where I have to find the lowest down part. And I really want to check a couple of places. I would check my endpoints, and I would have to then also take the derivative of, well, not really that, because it's not a function. I'm going to write it as a function, but I would have to take the derivative of this and set it equal to 0, and that would probably give me another candidate. So let me see if I can show you what I'm talking about. So let's go ahead and just name this as a function. The total number of bees, T of X, is equal to the starting amount of bees, 35, and then plus the entering bees, which would be the integral from 0 to x of E of t dt, and then minus the leaving bees, 0 to x of L of t dt. And I want to know when this total number is at a minimum. So I would want to know when, or a possibility would be when the total equals, or when the t prime equals 0. That's really what I'm trying to figure out. Okay, so I would go ahead and take the derivative here of both sides. And I don't know if I can squeeze that in over here, but I will. So this is going to equal the derivative with respect to x of this entire expression here.
Nice.
Yeah, I'm just looking at the variables. I feel like my variables might be a little bit messed up, but I think they're okay. All right. Okay, good. Thank you, Mark. All right, so then the derivative with respect to x of capital T of x, and this was arbitrary on my part. I could have called this capital B of x for bees or something like that, but I just called it T. So T prime of x is equal to the derivative with respect to x of 35 is 0, and I'm just going to write that down, although I don't have to, plus the derivative with respect to x of this integral, this is fundamental theorem, is going to be of x. And then the derivative of this integral expression with respect to x is going to be another fundamental theorem, L of x. So basically, I'm trying to figure out when does E of x minus L of x equal 0. So E of t, and I remember Mark saying this earlier, E of t and E of x, it's just really a variable swap. I can go ahead and substitute in 16x minus 3x squared, and then minus my L of t. I'm going to be careful with my parentheses this time. Woo, it's like the day of the parentheses. Okay, and then I'm going to go ahead and do a little bit of combining here. In fact, I might sling this 3x squared to the other side, get it positive. 16x minus negative 2x, would that be 18x, yes,
Yeah.
but I'm going to bring it to the other side because I think I'm getting ready to factor. Minus 15, so that becomes plus 15 to the other side.
I really like the multiples going on here.
I do too. Divide everything by 3, and so you have x squared. 0 divided by 3 is 0. By the yeah. So I tend to do that a lot when I'm looking at quadratics.
I consider the 0 the Sarlacc pit. We're just throwing the 3 into it.
How's the child doing, by the way, Mark?
He seems to be all right. He's
so
fiddling
cute.
with some controls over here, but
He's so cute. We're going to have to get a better look at him towards the end of class. Okay. Factoring here, I'm getting x is equal to 5 and x is equal to 1. So again, this is what I would call the candidates test. Thinking back around November, we might have done some extreme value theorem with the candidates test. Maybe haven't done it in a while, but in any case, on my table here, I might put 5 and 1 and my endpoints, but actually 5's not even on my interval, so I'm not even going to put 5 as an option. Just 0, 1, and 4. So this is the time.
Oh, go ahead.
No, go ahead.
I was just going to say, in case, because not all textbooks or teachers necessarily know it as candidates test. So just a reminder that the extreme value theorem is for any closed interval of a continuous function, and these are all polynomials. There has to be a minimum and there has to be a maximum, and it has to occur at either the endpoints or the critical numbers, which is what Verge just found, the 2 critical numbers for this function. So because I think that was actually a reading convention that started calling it the candidate test. But in any case, the candidates are the critical numbers and the endpoints. So.
Okay, good. Thank you for clarifying that. So at time t equals 0, that was at the beginning. There were 3,500 B's. I've kind of lost it off the screen there, but 3,500 B's. At time t equals 4, I think that was what we had for 55.
Yes, and I was going to mention, I don't know if you said 5,500 when you answered part B, but it should have been 5,500, right? I know.
You mean this?
Being a troublemaker today. Oh yeah, never mind. I was just paranoid after the first one.
I know. Well, I'm glad that you're not fuzzy headed today, because I sure am. Okay, and then how am I going to figure this one out? How am I going to figure out at time t equals 1 how many bees are in the hive?
Man, if only you had a function somewhere for the total.
Okay, so I guess maybe I could do the same thing I did here, except what? 0 to 1?
I was even thinking that t of x on your part C, just plugging in 1 in.
Yep.
Looks
but
like
I'd still have to come down in here and evaluate, correct?
Yep.
Yeah.
Yep.
Okay. So basically, I'm going to say, let's see if I could do this up here. I'm going to say 35 and then plus 8 times 1 squared and then minus 1 cubed and then minus the 0 times 0, so not too worried, and then minus, and then over here I have negative 1 squared and then plus 15 times 1, because, and then minus the 0, 0, because like you said, polynomial. These are all turning into 1s now. So 35 plus 8 minus 1, and then minus, this ends up being 14 in here. So I don't think there's anything pretty that we can do.
Not really. In
terms of combining stuff that, do a 10 or whatever. 42, this is a 42 right here, and then minus 14 is maybe 28. 2,800 B's.
28, just like the warm-up.
Oh my gosh, that is creepy. Okay, so right here I'm getting 28. So find the minimum number of bees in the hive. I would say the minimum number of bees is going to be 2,800 bees. And justify your answer. when you are asked to justify, that is the absolute highest bar. You have to be very explicit in all of your work and leave no stone unturned. I used extreme value theorem here, but there's another way that you totally could have justified this. If you want to talk about that a little bit, Mark, before you go on to the rocket problem?
Because it probably occurred to several students of like, well, why didn't, when you found that t prime of 0 and 1 was the only critical number in the interval, why didn't you just use the critical number? Because that's how we find relative mins and maxes, but we want absolute. So you have to make sure those endpoints aren't higher. And so that's what Verge did by finding her 28 was lower than 35 and lower than 55, since those are the only 3 values that might have been the minimum. But if she had done a sign analysis on it and looked at when is E of t greater than L of t, and you could do that by taking your derivative, which I think is the 16x minus 3x squared minus negative 2x plus 15, that line right before she started trying to factor it. If you took that and you plugged in, you know, a number to the left of 1, like say 0, and a number to the right, like 2, and you could do a sign analysis and go, all right, this thing is decreasing up until 1 and increasing after. So why can't I say that's the minimum? Well, that's a local argument. So you would just have to be very explicit, and you have to say that between 0 and 1, we know the function is decreasing. And then from 1 to 4, this total number of b function is increasing from that point on, so that you cover the entire interval.
And you're not just talking about a little bit on the right-hand side of 1 and a little bit on the left-hand side of 1.
Which is what we do with a first derivative test, right?
Right, right. Yeah, to talk about a local min or a relative min.
And likewise, you could do a second derivative test the same way, but it's still a local argument. You have to talk about the fact that it's continuous and there's no other critical number between 0 and 4. So.
Okay, good. So this particular setup, I think, lends itself really nicely to extreme value theorem and testing that way. But anyway, it can be done another way. Okay, so Mark, you're going to go ahead and do the rocket problem.
Yes.
So those of you who have your problems already from the shared folder, you're going to want to try and find that rocket problem. And it is, yes.
Oops,
from 2006. 2006.
It is from 2006, the 1 year we read in Louisville. And I didn't realize I'd closed that. Okay. And hopefully you can.
Yeah, what? That is right. We did read in Louisville that 1 year. It was 2006. I was trying to remember.
No, I take it back. That was 7. No. 5 and 6 were in Colorado. Not that this matters to anyone watching.
No, I was gonna,
yeah. 7 was Louisville. 6 was our last year in Colorado. Oh, all right. And so this is 2006 number 4. I'm going to go ahead and blow it up full screen for you for a second. And hopefully without rotating it, which is what I always do. All right, so we have a table we see at the top, and I'm usually not interested in the table until after I've read the thread. So rocket A has positive velocity via t after being launched upward from an initial height of 0 feet at time t equals 0 seconds. So we got a lot of information there. We got units, and the velocity of the rocket is recorded for selected values of t over the interval from 0 to 80 seconds as shown in the table above. All right, so that's what the table is. I notice it gives me 10-second increments and the velocity at each of those points.
Yeah, I think that's a really good observation because a lot of times our increments are not uniform at all on AP questions. Yeah.
And intentionally so. To keep you from using formulas and things like that would calculator tools. Although this was also a non-calculator problem. Let's get you centered there. So it says A, find the average acceleration. So I'm going to start with the average acceleration from 0 to 80. And it says indicate units of measure. And I'm going to actually do this the way I probably would have done it as a student first, because I didn't pick up his words as much. And one of the tips I give my kids, if my kids are watching, hi, I'm sure you guys are sick of hearing me say, you got to keep your pencil moving. You don't want to just stare at this thing. And we started Monday looking at average value. And I think as a student, my first impulse would have been to do this and look at the average value of acceleration. And it's going to lead me to the place where I would have gone as a calculus teacher off the bat anyway. Because what is the antiderivative of acceleration?
Velocity.
Velocity. So this is v of t from 0 to 80, which will be v of 80 minus v of 0 divided by 80. And that's where I would have gone as a calculus teacher, because average acceleration is the average rate of change of v.
Mm-hmm.
And average rate of change of v, to me, when I see average rate of change, that's a slope of v, which is, again, what I got right there. So 2 routes, we end up at the same spot. I still need to get a numeric answer, but I can come over here to my table, and v of 80 is 49, and v of 0 is 5. And I can leave it as 49 minus 5 over 80, or 44 over 80, or even, what, 11/20ths?
Mm-hmm.
Or frowning over 20, I guess.
Mm-hmm. And it says indicate units of measure. Hey, I think we lost Mark. Sorry, everybody. I am very confident that Mark is going to come back to us any minute, but I believe that we just lost him. So he was in the process of talking about this problem here, which is the rocket problem from 2006. And he had just calculated the average acceleration of rocket A over the time interval from 0 to 80 seconds. And he was just about to say what the indicate the units of measure. So that's where I'm going to go ahead and pick up. So I got to get my little scissors out again. Here we go. And so it's this little part right here. Where he had said 1 over 80 times the integral from 0 to 80 of a of t dt. And this was equal to v of 80 minus v of 0 all over 80. And he came up with 11 over 20 after he had subbed in those values. So what would the units of measure be? Well, as I look at this, I think to myself, acceleration was in feet per second. And then I went ahead and I multiplied feet per second times my dt, my seconds, and those canceled. Oh, sorry, that was feet per second squared. And those canceled, so then I only had feet per second. But then I came along and I multiplied by this 1 over 80. So this is back to feet per second squared. Those would be my units of measure for my average acceleration. Okay, so part B says using correct units, explain the meaning of the integral from 10 to 70 of v of t dt in terms of the rocket's flight. Use a midpoint Riemann sum with 3 subintervals of equal length to approximate that definite integral. So me personally, when I usually do these, I go ahead and I make my calculation first. I do my midpoint Riemann sum first, and then I might go ahead and write a sentence about what that means in the context of the problem. So let's go ahead and take a look at that. I remember Mark doing, it was a right Riemann sum the other day, and he was looking at the table. We're going to go ahead and now do a midpoint Riemann sum. So from 10 to 70. So we're only talking about from t equals 10 to t equals 70. So my first interval would be from 10 to 30. My next interval would be from 30 to 50. And then my last interval would be from 50 to 70. I'm just going to get myself enough clean paper that I can do this. Okay. So then from 10 to 30, I would have a width of 20, and then I would be multiplying it by a height of 22. Plus, on my next interval, I have another width of 20, but I'm multiplying it by a height along on the midpoint of 35. And because these widths are even, or uniform, I guess I should say, I can just factor that 20 out, which is what I'm doing. And then plus on the next interval, I have a height of 44 on that midpoint. So I have 22 plus 35 plus 44, all times 20. And this is getting me this approximation for this definite integral. And I had done this earlier today, so I'm just going to take a quick look at what I got. And I had gotten 2020. And let's think about what the units would be there. I'm integrating velocity, and so I'm coming up with feet. Using correct units explain this meaning. So that would be the rocket's height increased by 2020 feet from time t equals 10 seconds to time t equals 70 seconds, something like that. Then in part C, it says rocket B is launched upward with an acceleration of a of t equals 3 over the square root of t plus 1 feet per second per second. So now we've got this other rocket. Instead of rocket A, we've got now rocket B. At time t equals 0 seconds, the initial height of the rocket is 0 feet, and the initial velocity is 2 feet per second. Which of the two rockets is traveling faster at time t equals 80 seconds? Explain your answer. So let me read that again. Which of the two rockets is traveling faster at time t equals 80 seconds? Traveling faster really means, oh, Mark, are you
I'm
back?
back. Yes.
What the heck happened?
It wasn't internet. It was a hard crash. My computer froze. Every screen was frozen. No input, Control Alt Delete, nothing. So I just went through a whole hard reboot. And sorry about that. Hi, I'm back.
Well, my work on this was, I think, okay.
I'm sure it was spectacular.
Well, if it wasn't, we'll find out. But I was just getting into part C to figure out which one is faster.
Okay.
At time t equals 80. I think I know for rocket A, I know how fast rocket A is going at 80.
Sure looks like 49, doesn't it?
It's 49. So I have to figure out if rocket B is faster than 49 or slower than 49 at time t equals 80. Do you want me to keep going right here, or you want to try and pull up your screen, Mark?
Let's see. It has an initial velocity of 2. And I actually know they did this one different, right? If you look at the scoring guideline for this one, which I know you guys don't have with you right now, I'm going to go ahead and I'll grab screen. Yeah.
Well,
oh, no, I can't. So I'm going to have to talk you through it.
I think, go ahead.
No, I was going to say, I do it as an accumulation, right? So we have an initial velocity of 2 plus the integral from 0 to 80.
Good.
Of 3 times t plus 1 to the negative 1/2.
Okay.
Just because I'm going to do that as a power rule, I would have rewritten it.
Okay. I'm just going to do this if you don't mind. Okay. There you go.
So
this is initial velocity plus this accumulation of velocity, because that's what's happening when we integrate the acceleration.
Oh, that's nice. I'm actually doing it here. So the integral of t plus 1 to the negative 1/2 is 2 times t plus 1 to the 1/2, because we add 1 and divide by 1/2 or multiply by 2.
Yep. We have this little 3 out front
and then
still.
the 3 is there and the 2 plus is still there. Although Verge tends to do the integral separate, right?
Well,
And
this
so,
case, this case, I guess it
and then
doesn't
this
really
is
matter.
0 to 80, but that 0 to 80 is only on that 6 times the square root of t plus 1.
Mm-hmm.
And so that's going to get you, actually,
Yep.
I don't know if I have the ability to, I can't, I'm not a co-host right now, so I can't steal your screen.
It's okay. So just talking through, it says 6.
Yep. Plus the square root of 81, right?
Mm-hmm.
Minus
then,
6 times the square root of 1. Oh, I bet I'm a co-host again. My chat bubble just popped up. Thank you.
6 root 81. Thank you, unnamed person.
Yeah, you can now. So that looks a lot like 54 minus 6 to me.
Mm-hmm. Plus
and
this
then
other 2
plus
from
the
before.
2, so that sounds a lot like 50.
Mm-hmm.
So 50 feet per second.
So 50 feet per second is the velocity of rocket B at time 80 seconds.
Yep.
And then
that is slightly more than 49.
And that is slightly more than 49. So which one is traveling faster? Rocket B is my answer. Good. Okay. All right.
Okay.
Well, should we wrap up a little bit, Mark?
Yeah. So let's see. Where do we want to go?
Why don't we, there you go.
Hey, full screen. Living live again. And now you can see baby. Now you can see he's not baby. We don't even know if it's a he or a she. It's just the child.
Just the child.
Okay, so here's our this slide. If you want to take a screenshot again, or more importantly, go to that website. Make sure you are sharing the cb.org/tech if you need stuff. And thanks for watching. In the Dropbox, you're going to find the 1.5 free response questions that Verge did, along with the half I did. You're going to find the warm. I don't think I put it in there yet, but we're going to put the warm-up slide in there, I believe. And then we'll put the answers up Sunday or Monday. We'll let you guys chew on them for a little bit. There's also 2 multiple choice questions at the end that are nice Unit 8 wrap-ups. And the first one in particular is really neat. We like it a lot. So if you have some time this weekend, I know it's a holiday, but maybe Monday morning, take a look at those. So.
Yeah, definitely. And thanks for watching. Thanks for having patience with us. I feel okay now because I guess I was the only one who lost complete connectivity a few sessions ago. So anyway.
And thank goodness we're both here.
I know. I cannot imagine having only one person.
And I know when it froze, so I was mostly done with part A at least. So at least it
just
like
the units.
I was writing the units in. I looked up, my camera had frozen, and then I realized no, everything had frozen. So.
And this is one of our dogs. We have 5. So you saw Luna.
Not ours, not our dogs. Verge's family.
Yeah, my family. They only have 1 dog, but we have 5. This is Peanut. So you saw Luna last Friday. All right. Cool. Bye, everybody. Bye, everyone. Thanks for watching us.